Welcome, everyone, to Networking, the theory behind how online multiplayer games work. Today, I will be talking about multiplayer in general. And when the first thing you look at is networking, the first thing that people think of when hearing the word networking is CS, and then they get flashbacks to like learning the OSI 7 layer model and the boring stuff, and then falling asleep, and then having to take midterms. It's torture, and you just want to get out. You really hate it. So eventually, you're trying to figure out how to escape, and you become Squidward, right? But I'm trying to change that mindset. I'm gonna try to get you guys hyped. So hype time. So for that, I asked ChatGPT to provide some inspirational imagery. It went a little crazy, but yeah, here you go. Get hyped right now because we're gonna change the mindset of networking. This is the ideal state. This is how you should be right now. You should scream like your minds have you know absorbed all the knowledge of networking. All right. Now that we've gone that down, let's get to the boring stuff, and then right after it'll start getting more interesting, I promise. So first of all, you need to know what a client, host, and server are, because people say a lot of different things. Some of them are true, some of them are not. But basically, the nitty gritty is a client is any sort of device that sends a request to something else, and whatever receives that request is the server. And the server sends a response back to the client. So a client sends a request, a server sends a response. And this back and forth communication is really important in multiplayer games. You're sending a request, I want to move to this spot. You get the information back. Okay, you can move to this spot from the server. And every client gets it. So you are sending your own requests, and then the server relays every client's requests back to each client. So this client says, I want to move to the right. This client says, I want to move down. Server gets it. It says, move this guy to the right and move this guy down to every single client so that they know. You know? And a host is basically anything that is connected to the internet, but in the case of how we're defining it, it tends to be what is a client and a server at the same time. So essentially it relays to all different clients, but it also happens to be a client itself. So if somebody's hosting a lobby, right, they are the server basically. So if they disconnect, the entire lobby crashes. But if they have a good internet connection, then everyone else has a seamless experience. That's generally a lot of like early multiplayer games. They're set up that way because they don't want to deal with server costs. Because if you use Amazon or AW or Azure, or there's like tons of different backends that you can use as server, like dedicated servers. But people tend to just like host it, or allow people to host it themselves, sort of like Minecraft started off with. People were hosting their own servers, and then they realized, we want to expand, we want to have dedicated servers. And then like larger Minecraft servers, they have like 24/7 running servers, so that they don't have a client that crashes. And this is where you hear like random stuff out there, relay, NAT punch through, peer to peer, headless. So you might be wondering what that type of stuff is. You might have heard some of these terms, you might not have. So a NAT punch through server is has to do with peer to peer versus dedicated server. So peer to peer, all the clients communicate with each other, and they get the information, versus a dedicated server is essentially what is like spreading things out from that central server. But peer to peer works through NAT punch through, which is basically a trick that allows players behind firewalls to directly to talk to each other. So it's really cheap, because what happens is after players establish a direct connection, they punch through the firewall. They've established a connection, then it's done. The server is no longer needed. And then after that, they have that connection to run through. The other thing is relay. So this just relays network packets. So essentially, you have servers that, like game logic occurs on each player's client, and ultimately, they act as like a central thing, which just keeps the time of the server ticks, as they call it, and that okay, and that is shared. Headless is just a server that doesn't run like the rendering part of the game. So yeah, I wonder who came up with the name Nat Punch Through as well. Yeah, a server essentially doesn't need to run the game beyond the logic. So if you've ever run a Minecraft server or if you've ever set one up on your own, you notice there's like a command prompt and a terminal that says generating world chunks. And it says like, player moved to this position, player joined chat, exited room. All that type of stuff is just printing out messages. And that's actually when you set up a server, you're running the server on your computer. And that server doesn't need to run Minecraft itself. It's just running that terminal prompt. And when you run Minecraft on your computer while that server is running, you're a client. And therefore, you're hosting and you're a client. So, because you're a client, you're just like every other player with your Minecraft game. And then your server with a terminal has that information. It's client hosted server. Now that we've kind of cleared that up, we need to get to the Great Divide. If you've seen Avatar: The Last Airbender, there are two factions. They're very against each other. They really hate each other, and it goes back to a deep-rooted history. But the truth is, it's sort of like a scam. TCP people don't necessarily hate UDP people. It's just a case-by-case basis. I just want to call it a Great Divide because some people insist on using certain things and some people insist on things. But anyways, TCP, as it says, is slower but more reliable, and UDP is faster but not guaranteed. And the truth is, TCP is not guaranteed either. It's just it's more reliable, and this doesn't mean that it's unreliable either. So I'll clarify things in a second. So TCP, basically how it works, it sends a request. It's a continuous connection. So it sends a request and says, "Yo, I want to establish a connection with you." And this guy says, "Okay, I acknowledge that you've sent me this request and I'm down." Then he says, "Oh, okay. Well, I've acknowledged that I've received your acknowledgement," which is really stupid to me, but it's called a three-way handshake. But yeah, so once they establish the three-way handshake, then they got that connection and then he can send stuff. The other thing is that this sends an order and it sends, um, you know, uh, reliably, because what happens is when you send packets over the network, they take any path that they can to get to the final destination. So there's a source and a destination. So when they take any path that they want, some packets might be sent like this, some packets might be sent straight forward, some packets may be sent like that. So ultimately when they arrive, they're not necessarily in order. So what TCP does, it just, figures out, labels the packets, and once they reach, it's like, oh, it arrived as 132. So let's, reorder it to 123. So that's all it does. And it makes sure, because it constantly sends information, this guy has to send an acknowledgement. Yeah, I received the packet. That's why it's slower, because he has to send the packets, make sure everything arrives reliably, and this guy has to say that he received it. That doesn't mean it's guaranteed, because it's possible that the connection, like the wire, literally is gone. Like, ultimately, connections are wired at some level, So if if you have some disconnection, some problem, this guy's not connected to the internet. It doesn't guarantee that you sent everything, but you're, asking for acknowledgement. And if he acknowledges that he received it, then you're good to go. If he says he doesn't receive it, you'll try again. Eventually, you might give up. There might be a timeout that you set. So this TCP, you might think, okay, that's perfect for gaming because, you need all the data sent. I don't want glitches in my game, whatever, right? And then we have UDP, and this is just send stuff continuously. It just needs that destination port, and then all it does is it just spams you. It says, okay, my position is 4 or 5 right now on a grid. It sends it. My position is 4 or 5 now on a grid. It sends it again and again and again. So it doesn't check for reliability. It's not guaranteed at all, but it just is fast because it keeps sending packets, and it's up to this guy to get that information. It's up to the logic of the game and how you set it up. And that's why it's a best effort. The thing is, your typical applications for TCP are file transfer protocol, web browsing, and email because you need those things reliably at all times. But games generally fall under UDP because live streaming online games voice over internet protocol. Because what happens is you don't care if it's not guaranteed, because what can happen is, okay, you didn't get the thing this frame, you can get it the next frame. It's fine because it'll keep sending the information back and forth. If you've ever seen any video like FaceTime, if you've seen anything like WhatsApp, I wasn't able to think of that. Yeah, WhatsApp or FaceTime, you can see that when the video gets bad, it doesn't lag. It does. If you have that, then people are just gonna have a miserable experience because that's what TCP would do if a bad internet connection was there, because it would make sure everything arrives reliably. But for UDP, it just some of the data is lost. That's fine. It gets a little blurry. It's fine if it's a little it's not perfect, right? It's like 480p, 240p for a second. Sometimes that quality drops. You're fine with that as long as you just get the data. So you want to make sure that you're sending out, it has to be like fast, it has to be live. The second that you start falling behind and it's not fast and it's not up to date, then you get like problems with TCP. And so generally games are on UDP. Then you have a Great Divide Part 2. And this is more once you decide. Also, by the way, really quickly, TCP, you can make games on TCP. This is not saying that you can't make games on TCP. It's just going to be a different kind of game. Like chess can reliably, or solitaire reliably runs on TCP because it's not real time, right? You just send the move, the server gets the move, and it sends it back. It's turn based. Card games, any card games can be set up with TCP. You can also do them on UDP, so it's really up to how you set it up. So yeah, but most real time games will be in UDP. Then here's the real question. Once you decide your thing, it comes down to sending state or sending input. And you can see 2 different types of games here. Valorant, which is an FPS, and then you have like a real-time strategy type thing like StarCraft type stuff. So when you have, the game that you decide, you have to sort of think about this first. And multiplayer, the biggest thing and the biggest issue that people have is that they start with single player and they're like, oh, let me add multiplayer. It's way harder to do that than to start with multiplayer. So that's probably how you got to think of it first. Like, oh, I want to do multiplayer. And then you decide the logic, because the logic is really determined by these types of things. So let me explain what that is. So let's say you're at 0-0. You're at the origin. You want to get to 2-3, move to 2-3. So what you do is if you choose the sending state method, right? You send that state to some authoritative server or some place of authority, whether it's a host. They calculate all that, and then they send the information and it back to all the different clients, and all the clients move that character to 2-3. If you say send input, uh, you're just telling people to move to 2-3. Every client on their own machine decides to move to 2-3, however it is. So logically, you would want this to happen the same way. All of them should travel to this final point. But sometimes, there might be slight things in the terrain, so he's not traveling perfectly. He goes to here, move to 2-3 like this. And then some clients might move it like that. And some clients might move it directly. So really, you don't have a perfect um, system, but it's up to you to really code that. So it has to be deterministic. That is a key word that we'll look into in a little bit. Okay, so if you're trying to move to a position, so basically, state versus input boils down to that. So the first thing is network traffic load. You're sending more stuff for state. So for a game like Valorant, that's fine. You want to get the exact precision of gunplay. If you're aiming at something, you need that exact point. You know, I'm pointing at this, character. I'm trying to headshot it. I need that exact precision. So just sending the input and letting every client figure it out isn't fair, because there might be a slight difference on the client. Maybe on one client it's like this, and then the other client it's like that, and that's the difference between a headshot. That's why you want to send state for something like an FPS. This is a little bit lower network traffic load for input, because all the logic happens on each client, so they don't have to send a lot more information. However, uh, you know, this isn't as precise, and that doesn't matter for certain types of games. For example, a card game, when you send an input, it should play out the same. If you have a stack of cards, they should resolve the same way based on your game logic. So it really doesn't matter that each player has the input on their own machine. Same with the real-time strategy. It's hard to code it with state because you have hundreds and hundreds of units that you're manipulating at once. Sending that much network traffic over something is pretty bad. That's why you don't see that. For an MMO, you actually send state because you're not manipulating 100 units per machine. You're manipulating your own character, and you're sending all the information pertaining that character to every other client. That's different because you're sending to many connections, and this one is sending to many connections with a lot of data per connection. This is just sending a little bit of data, or it's still a lot of data because it's state. This is not a lot of data, but if you had 100 units, that would be a lot. So that's why you want to generally send input. Reconnecting, it's easy with state because all it does, you just have to get the state at that moment of time, and you just reconnect. Input can be harder. There is an asterisk here because exceptions may apply. Basically, what would happen is that once you disconnect, to rejoin, you would have to replay the whole game from the start, in the sense that not you, but the server or whatever is there, it's going to have to, because it's deterministic. It says, okay, first the move was E4, then it was D5, and then the Scandinavian happened, and the whole thing, like, it replays it very quickly and gets you back to that position. Because it's deterministic, it will always get you to that position. But it's hard to code that. There's no tools like that already available. So that's the reconnecting. Replay file size is large because you're sending a lot more. This is just small because it should be deterministic. So no matter what, playing it on any machine should yield the same result. So the file size of the replay is small. And the ability to cheat is way harder with state because, like I said earlier, when you say move to 2-3, the server will calculate that and relay it to all clients. The clients are not doing it on their own machines. based on the input that they get, right? So the ability to cheat is a lot harder for state versus input. So let's talk about some cheating because you guys are thinking about that, right? So yeah, you can see this guy has some wall hacks slash, probably even aim hacks, right? So here's three situations, right? Let's say a player hacks their HP. They start at like 50 HP, they hack to like 200 HP, something like that. It's it's a little bit problematic. You want to make sure that doesn't happen, right? So in the sending state model, what happens is they're not there's two situations because in the sending state model, you're either a host or you're a server. Okay, a host, so whoever hosted the lobby, if it's a public server, then they're cheating. It's like lame because they have uh you know it's gonna be a problem because they have control of the server. Essentially, if you start a Minecraft server and you start cheating, you have control of that server. So essentially, you can cheat to your heart's content. However, if it's a dedicated server, like a FPS like CS:GO, an FPS like Valorant, all those games, they even League of Legends, game like that, right? They all have their um servers that are dedicated. No player has that on their own machine unless like even a custom game is through their servers. Um so generally what happens is, the next time the game state is synchronized, like cuz the server keeps sending the information to the clients. If the guy changes his HP from like 100 to 200 or 5 to like 700, the next time the server sends back the information, it'll see that okay, that's not right. So it's just going to send back the 5. So that's literally no problem. For sending input, however, what happens is you'll have a desynced gameplay because the local guy, the guy that's playing, he's going to be like, "Oh, my HP is 500." Everyone else will see his HP is 100. So they'll have like a desync in the gameplay because what'll happen is as soon as you shoot someone and you deal 100 damage, they might die, but on their machine they have 500 damage, so they're not gonna die. That's gonna be really weird. So what happens is there could be some glitches there, and what you should do is code it so that if there's a desync and you detect a weird desync for a long time, uh, an initial slight desync could be because it's lagging, something's happening, so you don't want to immediately kick them out. But if they're like desynced for a really long time, there's a problem there. They're potentially, you know, cheating, and you want to kick them out. Another thing that you can do is you can reenact and validate the player's session. So what you can do is you can do multiple things at once, by the way, and a lot of people do multiple solutions at once. What you can do is reenact the player session, and what would happen is, as you have that deterministic behavior, the this guy's computer is not going to follow the rules of the game. So what's going to happen is he's going to have a weird experience. He's going to glitch. He's going to be in places that he doesn't know that he shouldn't be, and so he's going to have a really bad experience. But we don't care. We don't care about the cheater's experience.
Let him suffer.
So yeah, that's what happens if they hack their HP. What about fog of war and wall hacks? Well, for sending state, you should only send the state that the player needs to know. So only things that they can see. So in Valorant does a fairly decent job. You can't see players across the map. You're only sending the state to like the footsteps that they hear, and if they, are sort of close, you give them a little bit of a buffer. So wall hacks still work in Valorant only up to a certain degree though. Like you have to be close enough, and it's like almost last second. So it's pretty good in that aspect. So you just want to send state at the last. Every machine doesn't have it, But when you're sending input, every machine knows the state of all the players at all times. So it's really hard to, stop it for the sending input. You know, if you're sending input, every player's position is known to each client. So there's no way to really stop fog of war wall hacks in that situation. Really, the only thing that you can do is make it like add like source code protection, binary obfuscation, just making it really hard for them to like parse that information. But it's just a matter of time. There will be a day that they can figure it out, and then once some guy figures it out and adds it to some cheat engine or whatever, some program, he can distribute it to people that aren't smart enough to figure it out. They just download the wall hack or whatever. So sending input, you can't really stop that one. And then finally, auto aim. Neither method, state, or input can stop that because that's literally just the local client. It makes his aim perfect. How do you know that they're not, like perfectly just landing every shot? That's not really something they can stop with, the server. That's just a local program that helps them auto aim perfectly. The thing with this though is that you can just ban players. Like once you get reports, that's why you should have a reporting system. Once you get reports, you just ban them. Any ban kicking out thing is really useful for cheating. That's cheating. So let's think about actually implementing these things, right? You pick input or state. So let's take input. It's a little bit easier because, it's not. Neither are easier. Sorry. Let me confirm. I said the wrong thing. They're not easy. Neither of these are easy. So sending input, well, we need determinism, right? So once this does something, this should play that exact same thing right after, like on every client. There will be a little bit of latency. Latency is just like the ping after, like once this does something, this will do something. Once it sends it over the network, it'll be a little bit behind. So the challenges with this is floating point errors. So if you've done any CS, even if you haven't done CS, floating point numbers are just decimals. And computers, the way they work, they approximate things a little bit. If you take like a 5-digit decimal, like 0.3145, for example, 31456, and you divide that by a 3-digit decimal, if you do that multiple times, you're going to get inaccurate results. If you put the same thing in a calculator, you'll get very accurate results. If you put it in a computer, over time, it's going to get a little worse. And if one machine gets you an approximation and another machine gets you an approximation, you're going to have a slight difference. So one block might land here and throw off your rolling trajectory slightly, and one might throw off your rolling trajectory slightly in here, and they're not going to be synced, and it gets worse over time. So initially they're slightly off sync, and then as it builds up, it's like the butterfly effect. A butterfly flaps its wings, that causes a hurricane on the other side of the world. Because if you've ever heard about that. But yeah, so a small change between things does not work. So this has to be perfect. As you can see, these are both perfect. This is just a second behind because of the time it takes to send over the network. The other problem with floating point errors, and this one's kind of crazy and annoying, is you could just, try to fix, make sure that floating point errors, you don't care about that level of precision, right? Maybe you don't need the player to, maybe it's like a turn-based game. You just have a whole number of coordinates or something. But each compiler, and each computer and Mac versus Windows, or even Windows versus Windows machines, based on the graphics card they have, based on the information, can cause slight differences in these floating point numbers. So you want to make sure any floating point numbers you use, they have to be the same. And it's possible, it's just very hard. So you probably don't want, or you don't want perfection in your games if you're worried about floating point errors. So a card game, or even if you have like a physical game, if you don't care whether players at this point or like this point, if that much of a difference is negligible, then it doesn't really matter. It just won't work for FPSs. That's why they never send input in FPSs, because it has to be perfect. The other thing is randomness. So if you roll a dice here and you roll a dice here, then if they don't come up with the same answer, then you'll have a different situation. So the way they do that is by feeding it a seed to both situations. So if you feed a seed, like a Minecraft seed or whatever, you'll generate the same world in both situations. The last thing is physics and logic. The physics and how they work have to be exact, and this is again the example. But yeah, so that has to be perfect, and that also ties into floating point errors. But yeah, that's generally the challenges with that. Now, what people do sometimes is introduce this thing called lockstep for determinism. Essentially, you're just waiting for all the clients before you advance. So, let's say a client says sends some data about where they are and some other data to the server, and then another client does it, and another client does it, and another client does it. You wait for all of them before you advance the game, and this might happen like 60 times a second or 10. Technically, for logic, you can do it like 10 times a minute or something like that. Because rendering on each machine can look smooth, but the logic might only run 10 ticks, as they would say, per minute. So yeah, there's tricks that you can do. One thing is latency. So you'll notice that if you're waiting for every player, what happens is the slowest player determines the experience. So if some guy has a really terrible internet connection, that's going to be really bad. So what you can do is affect the visual layer and animations, like a cast animation. You can see like Cinderace? I forgot. Is that Cinderace? I'm sorry. It's been some time since I've played Pokemon. Don't sue me. But you can see that the Fire Bunny chick, Cinderace, can anyone confirm? Is doing like a whole
Fire Bunny chick is
That is the name.
Okay. Just making sure. Yeah. And then Greninja, they have like this whole cast animation. And that sort of, if you have a latency thing, the damage is applied afterwards. So you're waiting for, the damage to apply. So that's a cool way to stop, to make the game look smooth, right? Another thing is like you can animation cancel if one player's thing starts like sooner. There's a lot of different visual tricks. You don't have to like make this lag or look bad just because of latency, right? Because you're waiting for all players. Another thing is if you have a guy that's spiking a lot, you can time it out. So you can say I'm gonna wait 100 milliseconds before advancing, and if I don't get some information from a client, let's say this guy's having an internet spike and it's not like loading at all, then essentially you just like ignore him and you're like, okay, I'm gonna send the information to all the clients. And what will happen is he'll have a slightly shitty experience because of his lag, but it's like, I mean, it's your lag, man. Get a better internet. Like you can't do anything about that at a certain point. If somebody has like really terrible internet, they're like in a jungle and they don't have any, towers near them, well, there's nothing you can really do about that. You can only do your best effort. Another cool, I put Jackbox in here because it's like a simple thing, right? You just wait for all the clients to give their answer. It's a lot simpler and a lot less data, and it still manages to be fun during the pandemic. Everyone's playing this. Okay, well, maybe you don't. Oh my god! Now I might have a newly developed fear. Okay. Well, maybe you don't want input then. You're like, this is such a pain. You have to deal with all this stuff. I mean, you don't have to introduce lockstep, but you need determinism. It's perfection. Sometimes you want that perfection. You realize that reconnecting is hard. You realize that you know, the replay or sorry, ability to cheat is easier. Like, you know what? Let's just send all the state. How much network traffic load could it be, right? It's just higher network traffic load. It's way easier to reconnect, even though it's a large replay file size. Maybe you don't even have replay as a functionality. Like, get this out of here. Get this input stuff out of here. Well, sending state, you need responsiveness. This is the problem. For sending input, we need a determinism, but it's pretty fast, like because every client is calculating their own stuff. It's happening live. Everything's pretty fast and buttery smooth. The lockstep thing is the only thing that could introduce potential lag, but even the rendering is pretty smooth there. Well, here's the thing. You need responsiveness. So if you're sending state, you need to have this concept of client interpolation. Oh, whoops. And prediction and rollback, right? Client interpolation, it's like you want them to have a smooth experience. So you got this FPS guy. He's okay. Ignore the hacking, right? Let's say you got a genuine FPS guy. He's trying to like position himself. He wants to get the players like right away. And you're sending all the state. It's being calculated authentically. Well, you don't want any lag for this guy. You want it to be as smooth as possible. It's real time. It's responsive. So what you want is this guy's local behavior. You just let him calculate it however he wants. He sends that information to the server. If he's cheating, you'll know right away because it's like he's like, oh, I was here and then I jumped through the wall. It's like, okay, well, we figured it out. You're cheating. If you're a little too fast, they're still going to detect it. It's like, okay, you were supposed to be at this position. You're at this position. What are you doing? So the server will immediately like figure out. They'll kick you out, whatever, right? So hacking isn't too much of a worry if you've implemented good cheat systems, whatever. So people aren't magically flying around in your game for the sending state method. But the thing is, like, you allow the guy to move and then you reconcile. You allow a little bit of leeway here and you reconcile with the server and then it updates your position. And it'll do it in a smooth, animated, seamless way. And your input will generally be pretty good. There'll be a slight lag and slight latency. It might not be perfect to like the exact T, but a headshot is still a headshot, right? So it's like this much to this much is not enough to like change it many times. So there's that. The other thing, so that the client interpolation, what that means is essentially you have your local character. He's playing in real time, but there's latency. So a player across, America is playing. He moves around. Let's say he's here. He moves to the right. Well, by the time he moves to the right, this information is getting sent to the player like a second later. Maybe not a second, but half a second. And for pros, that's like immediate. Like they have immediate reaction time. Like they have less than half a second of reaction time to like shoot someone, right? So if that data is happening, what you're actually seeing on your screen is where they were a half second in the past. So if you shoot someone and they go to the right a little more, then somebody's going to have a bad experience. Either he's going to be like, hey, I hit that shot and it didn't hit, it didn't detect. Or this guy's going to be like, hey, he hit me even though I moved to the right already, right? So what you're actually doing is you're sending data, you're keeping track of the past data on the server, and you're reconciling that with the current data of the player. That is the interpolation that's going on. So it's like time travel. You got this guy, and he's playing against players in the past. So everything that you've been seeing is slightly a lie, right? When you play FPS, you're playing people from the past, not people live. And it's generally pretty good because latency if you have ping of 100, then it's starting to get like you notice the delay. You start noticing the delay. But generally ping is like 50, 40. Uh for if a game is has good servers near you. But if you play, you'll notice it clearly if you play across the world, right? If you want to play Koreans on their Korean server, it's not gonna be good as a League of Legends player because those guys are playing on like 8 ms ping, and you are playing on like probably 120 ms ping. So everything that you do, there will be a slight delay. It'll still look smooth with the animation, but the animation will play slower or something like that, and things will happen on their machines. So ultimately, this interpolation thing is a challenge. It's a really big challenge to implement. The other thing is prediction and rollback. So when a player is moving, generally you want some, level of client prediction. Also you can see right here, by the way, I didn't really point this out, but you can see the server versus the client. There's like slight differences. So the other thing is we have like players input, and we use that to like determine the game state on each machine. So you might have a level of input that you do locally, but you don't send that to every client, right? And then as soon as you move that player locally, that prediction is sent to the server. And then if there's a slight difference, it rolls it back, it moves it back to where it's supposed to be. So doing this well and doing this in real time, doing this so that people don't have a bad experience is another challenge. Right? You want to predict where they're pointing, where they're aiming, and then like you want to have that done locally, because if they have to wait for the server, there's going to be a little bit of lag. This stuff has to be seamless, and if you're playing an FPS, basically this whole message, I dropped a lot of FPS stuff. I don't really play FPSs. I'm gonna be honest. I'm not an FPS fan. Sorry to those of you that are like diehards for like CS:GO, Call of Duty, Valorant, like literally any, I don't know, Apex Legends, any FPS out there that you love. It's basically what I'm saying. Don't make an FPS, right? It's gonna be hard. It's gonna be challenging. It's gonna be a lot of work. You're not gonna like it, because it's very challenging. But a game like Terraria, right? It's very doable because even if you send state or input or whatever, uh, you can have local servers where they host their lobbies, right? Players play. If they're cheating, you don't care too much because they're ruining their own experience. If it's your own friends that set up a lobby and they're hacking, are you gonna really like play with them again? It's like, okay, bro, you're cheating. I see you like flying across, or sometimes all of you cheat together for like some stupid thing. Like there's some stupid item with like a 0.0001% drop chance, and you're like, okay, is that we farmed for like 17 hours? Like we're done. We're giving ourselves the item. Like I think we've earned it based on the time. Whatever. Some people cheat like that, and it's like, okay, well, in that case, you don't really care as the game because it's not like competitive integrity. It's not competitive. If it's a competitive game, then that's where it starts becoming problematic. You really need to like stop cheating. You have to stop like you have to make sure everything's like perfect, real time, smooth experience for all players. That's when it starts becoming problematic. If you're doing like a local, even if it's like a co-op game, that's great, right? You don't care about the perfection of positioning. If a player is, as long as like like an attack is like a big circle, right? Area of an attack that a dragon shoots a fireball, it's landing right here. You got an action RPG, the player moves out of the way, it's pretty good. Like, and generally latency, all these things aren't problems uh on an average internet connection. It's only when things start lagging that you have a slight, you know you have to have some mitigation. That's why you add stuff like timeouts, you add visual layer animations, you do stuff like this to make things better. You know? So that's basically generally most of the stuff regarding you know multiplayer. So I just wanted to kind of go into a couple more things, and that is some learning resources really quickly. And these I mostly work with Unity, so I can only really vouch for this. I did find some Unreal and Godot guys, but basically these guys are my bread and butter. So let me just show you guys some stuff first. It's kind of cool. YouTube. Let's go to Taro Dev. I love this guy. He does a lot of different stuff, like animate. Like he's good at CS, so he's made some like cool stuff. I think this one's a good video in general if you're just sort of new to games and stuff. He built a 2D platform controller with. Oh, you link the. I'll link all. Of, don't worry. The whole slides thing is gonna be shared, so everything will be linked to you guys. Don't worry. Okay. Anyways, basically this guy made a whole platform controller with different sort of information. Right. So this is a very basic thing, but he's taken. If you just search networking, right, he has tons of tutorials here. Like he shows Unity online multiplayer, shows global matchmaking, um, how to set it up with Unity stuff, and netcode for game objects. Right, that's the Unity thing to set it up. And then you also have stuff that you can set through Unity gaming services to have a lobby. Anyways, it makes things a lot easier. Makes things easier to understand. He even shows you, custom servers. Building a custom server for your game, part one and part two. There's even this gaming backend with Loot Locker. So sometimes you want a dedicated server, you'll get some like amount of free stuff. I believe with Loot Locker. Forget. Sometimes you're willing to pay a little. That's fine. You're there. Sometimes you just want each player to host their own lobbies. By the way, if you the thing about hosting lobbies, it's just running on their internet connection, so it's not really any cost associated with that. Like it's just their general Wi-Fi cost. It's not gonna like add up or anything. So you don't need to worry that oh yeah, now I'm charging the players or something to play a multiplayer game. That's not really happening. Like it's just when you play CS:GO or League of Legends or whatever, right? Uh, it's basically the same thing. Or even if you've set up a Minecraft server, uh, well, the thing is, those are dedicated servers with the League of Legends and CS:GO, but it's like it works the same way in the sense that if you host a lobby, uh, you're setting up some relay service where they're just they essentially don't need to think too much. Like they don't have to like set. So in Minecraft, you have to do this thing called port forwarding. I'm not gonna look that up right now, but essentially there's a bunch of tutorials on that. But port forwarding is really annoying, essentially, for players to set up on their own. They have to go into their router settings and all that stuff. So instead of that, you can set up a relay server, Steam Relay, for example. If you put your game on Steam, they have this thing called Steam Datagram Relay. It's free. Basically, all it is Steam establishes the connection, so you don't have to send your IP address to someone else. That's annoying to do, and there's like all this firewall stuff. So instead of doing that, you're just doing it through their Datagram Relay server, and this isn't a dedicated server here. This is just peer to peer. So each player will host their own lobby, and whoever connects to that lobby will be playing on their local machine. You know, but they can connect. This is really cool. Then there's Dapper Dino. Uh, he does tutorials for this thing called Mirror. It's really useful. He teaches a lot. It's really good too. I really love his original Mirror multiplayer playlist. It's so easy to understand. He talks about, the client server relationship initially. Starts like explaining how Pong works. And then he shows, ownership and authority. Because players, they have authority over themselves, but even that they should send to the server uh, to determine if it's okay whether they're somewhere. So he goes through all these like tutorials. This one is really good, I think, to start actually learning. And then you can even switch over to netcode for game objects, which is Unity's thing. It's very similar to Mirror. It's very similar. So it's really useful. Oh yeah, he just showed some game that he made. He showed like an example behind the scenes of the lobby system, and it makes complete sense. And then he later goes into that. He actually shows you how to build it, network managers and all this stuff. And it's super useful even to make a chat. I coded some of this stuff, by the way, in the past. Like I built a chat. It was really interesting. You can also have like chat filters and stuff if you care at all. But the lesson I learned is there's no way to stop people. The other thing is like, yeah, this whole lobby system is super useful for, spawn players in. He just does beans, but like you can even do animations. You can do stuff without animations as well. You can make the animations play on a local player's machine. So if the movement speed is greater than 0, it will just play a run animation. So if you see some character moving from one point to the other, they will automatically just play a running animation. If it's turn based, it's easier. If it's a card game, it's even easier. If it's a trivia game, it's even easier than that. Camera movement, yeah, he shows a lot of different things. Network messages, syncing events, map handling, input blocking, rounds, basic combat. There's just so much that he shows. And then he also shows how to set up a dedicated server if you want to, level up using PlayFab. PlayFab, I believe, is through Microsoft Azure. Yeah. Super useful, teaches you a lot of stuff. This would be headless. Like I was saying, headless. It runs the logic, but it doesn't actually run the game itself. It's a dedicated server. It just runs the logic of the game and relays it back to the players. That's that. Yeah, authentication for logins, right? There's a lot of different things like chatting, player identity, and authentication. There's so many different things that you can have and do. And yeah, that's that. MS Farzan does card games. Yeah, tabletop card game. This is very basic. Like it doesn't look too great, but if you have your own like good art, you make a card game. He kind of shows you how to set up. He uses Mirror as well. But yeah, that's that. Then you have Honest Dan Games. This one is for, I mean, this isn't this is just like a two-parter tutorial, but it's pretty. What is this? Yeah, part 2. He does a walkthrough, showing how it works in Unreal with like a lot of stuff. But yeah, this will at least get you introduced to running it in Unreal Engine. I'll send that, but just in case you just want to look it up quickly, Honest Dan Games. Ditsy Ninja's Godojo. This one's kind of cool. He has a bunch of different things. Like he talks about dedicated servers, headless servers, cloud hosting, a lot of different things. This stuff more recently is more on rendering, I guess, but there's multiplayer, spawning, peer to peer over the internet, the easy way. Pretty sure that's not easy. There's just some cool stuff here. That's this guy. I can't promise that these are like amazing tutorials because again, I work with Unity mostly, but I just kind of browsed them a little bit. So yeah, I found those. These are more general. Ryoyu Sun is what I talked about today most because it really explains the basis. It gets down to sending state versus input. What you want to do, you know, that's the main part of it. And then going back to this, yeah. So this guy has a lot of interesting stuff. Ryoyu Sun. Um, yeah, should probably type in Game Network. See, Demystified. He has all this stuff. He has more lockstep, server network topology, interpolation, rollback. There's a lot of stuff. Then there's also Gabriel Gambetta, who does fast-paced multiplayer. This is another interesting thing that this goes more into detail. You know, the client server times and ticks and stuff. It goes more into the nitty gritty math and detail. I don't want to jump too much into this because it can get boring also, as well as for a workshop, it's a little complicated to like cover in one time. But you can go through this. It's a bunch of different articles, part 3, part 4. And then he has a live demo where you can actually see prediction, reconciliation, interpolation. Then you can move and see how. But yeah, that one is just a live demo after you understand everything, right? And yeah, you can mess with the lag as well, whatever you want. That's interesting. It has like good explanations. And this guy, he's amazing. Gaffer on games. This guy's done Glenn Fiedler. He's done GDC talks as well. You can look up Glenn Fiedler. Um, I don't know why the website looks like that. Should something's off. Something's off here. But anyways, they have plenty of UDP versus TCP, all this stuff. What every programmer needs to know about game networking, floating point determinism. Actually, I think this is where. Wow, he changed to mass bandwidth. Mass bandwidth. What is this? I guess he stopped on here. This is literally like a last week thing or this week thing. This is unique. But yeah, there is. Wow, literally like 2 days ago, I was looking at this website. It was different, but yeah, it was essentially all these articles, but there was like it looked better. But yeah. Anyways, he has a lot of interesting stuff. And then he started this thing called Snap. No, it's not this. Network Next. There we go. He started this thing, which is really cool. It's like its own series of networks that's set up, uh, which makes like latency faster, which makes game experiences really good. And they set up a bunch of servers everywhere. Just makes games overall perform better. A new internet is what he calls it. I think it's a little dramatic. It's not a new internet, but it does improve stuff. I don't know if you're interested in that. Anyways, he's this basically the point is this guy like really cares about games. That's that. And then here's some links and tools. So again, TCP versus UDP, choosing TCP or UDP, a guide. So yeah, you'll be told that you can't build anything fast with TCP. That's not true. UDP is always faster. It's not necessarily like it depends on how you implement stuff as well. But yeah, they'll explain a lot of different things, and then that's a good, useful thing. YouTube. This one's a Photon versus Unity type thing. Unet, which are two different Unity stuff. Those are some things they can watch. And then this one is Dots for Unity again. I do have more experience with Unity, that's why I did drop a lot of that stuff. Between two servers is a podcast. I think it's the same guy, Glenn Fiedler, but he talks to a lot of different people outside, like Respawn lead engineer, Apex Legends. He talks to a lot of these guys, and they explain how they implemented it. If you're using Unity, you can use Unet, Mirror, like I talked about. But there's also Photon. It's not an engine per se. I mean, it kind of is an engine, but like you can use it in Unity. They explain all this stuff. What this is good for, what is this good for, and they have like a free level, right? Up to a certain point, like up to a certain number of users. Then, like they either shut down the server if you go like way too crazy, or you can determine 20 concurrent users at the same time. Um, Development, but then for launch you can do 100 concurrent users, which is free. That's for this quantum or whatever. There's real time infusion as well. That's that. And Peril Sync is a really cool package in Unity itself. If you are using Unity, you should download that pretty much instantly. It's so useful because it just lets you open multiple clients on the same machine, so you can test like a multiplayer game on the same machine. You could even connect to like a controller, and then have the controller play on one, and then play with the keyboard on the other, something like that. Just messing around with how depends on how you built your game. But Peril Sync is the way to go. You can run multiple of the same Unity project essentially without having to open them and then having issues with how it clones the project, but it doesn't clone it in a way that like it deletes it, I think, as well after close it or something like that. But yeah, I've used this before, super useful. And then Heathen Steamworks. This exists for Unity, Unreal, and Godot. I mean, it's a light version right now for Godot, but yeah, full version's coming out. But it's generally there's like a free tier. I think the free tier is what Godot already has. But yeah, this is super useful because it helps you implement Steam. And this is what I'd recommend for a lot of you guys, because Steam has a whole ecosystem set up. Most of the time, you're trying to release your games to Steam because that's just a lot of games are on there. It's how you get noticed. This is the I think this probably should be number one here, but yeah, I didn't really include that as number one. But essentially, yeah, you can see Unreal, Unity, and Godot. They have their own. You have a friends interface, stat and achievement, user data, app API. But the complete version exists for Unity and Unreal. The foundation version exists for Godot. They help you use like Steamworks.net or Fizzy Steamworks or whatever Steamworks exists to uh, implement it into their servers. I did work with this once to build something, and you can see I have a friends list right here that you can scroll down. But basically, like I got the profile pictures and the names uh, populated by uh, Heathen Steamworks. Like I didn't manually put each one. That would like take forever. I would hate to do that. Basically, it just fills up a list. You can see I have like a friends list right away. Um, and that's through. I mean, I still had to code a lot of stuff for this to be set up, but it's still like having APIs and things like that makes it a lot easier. So if you're trying to implement a game within Steam, super useful. Postman API, it is, I mean, overall, this is good for outside of game development as well. But it's useful for like there's a lot of different. This is a very generalized thing. Oh, there's that. Well, I just wanted to do a quick multiplayer demo giveaway contest and tell anyone about this, but it's a surprise sort of thing. It's a it's a giveaway, but it's also a contest. Um, Essentially, the rules are you have to be a registered member of the club during spring of 2024. So if you are currently a registered member, you're good to go. You're allowed to be in a team, but only one person should be the point of contact, right? Like, just decide your person, right? You can be in a team with other non-qualifying people. So if they're not registered members, if they're alumni, that's fine. But the point of contact must be registered. So, like, whoever I contact, whatever, they have to be registered. Just let our board know, anyone from the board, of your participation by May 1st by sending them your name and email, not not slash. Sorry, it should be name and email through Discord DMs. I guess you can message me, but I'd rather you message them because they actually know who's registered and who's not, so that I just get a list of registered names and emails that I know how many teams there are and whatnot. So after 3 months, I want you guys to make some multiplayer tech demo. So by August 1st, so May, June, July, you have like those 3 full months, um, essentially to build any multiplayer tech demo. It does not have to be a full fledged game. Just some sort of prototype or something to show that it's. But make sure it's fun. Like try certain ideas. You can try building some like single player thing on your own quickly. Just try it out for fun, and then eventually release on August 1st. You have to share it. I'll give you probably more details on which email to share it to. But essentially, once you share it, I'll uh, another thing, the board is eligible for participating. The thing is, okay, actually I should have honestly the rule order is terrible because the reason the board is eligible is because the judging will happen by anonymously sending your demos to my friends to rank. So I will share these games demos to my friends to rank them. They will be anonymous, so don't include your name in any screen or credits. If I see that, I will ask you to resend it without that. Um, but yeah, so that would be my kind request. And essentially, yeah, I would just send it to my friends, not the board. So that's why the board is eligible. The other thing is you must show proof of when you start, right? So if you have an existing project, any build 3 months from that start date will be accepted, right? To even the playing field. So if somebody already has a project in progress that they've already been building multiplayer for, like maybe one of the game pitches or whatever, I just want to see like a 3 month demo essentially from that start date. Any build 3 months from the start date. Otherwise, if I would prefer, that you start a new project and then show me a 3 month tech demo multiplayer game, and that is what will be ranked. Okay. And finally, one individual or group, whatever you are, right, will be chosen for $100 Steam fee prize. I'll pay for your uh, Steam fee upload, so you will be able to upload on Steam, and you'll even be able to. So that's the thing. Like when you want to put a game on Steam, it has a fee of $100. If you didn't know that before, we'll work out those details later once someone has been determined. That will be like August 1st. After that, like I'll have to give it out to judge, so maybe end of August, something like that. And maybe you can take it further. Take this tech demo further, make it into more full-on multiplayer game. Because most of the time, I just see people working on single player. It's great to keep your, like it keeps your scope small. You can do a small scoped multiplayer thing too. For example, like I said, the trivia from Jackbox, it's fairly small. Like you're just asking trivia questions. It doesn't require much coding on the logic end there, but it can be fun because like Fibbage is a really fun Like it's a creative game idea, right? Other thing is like chess. So I actually forgot to write this in the rules. But one more thing, I don't want to see like games that already exist like one to one. I don't want to see like chess done again. If you can put a spin on chess, you can do some like unique thing. But I don't want to see like a one-on-one pre-existing game. Like I don't want to see like Super Mario Bros, but like Super Wario Bros or something, Exclamation point, question mark. Yes. Yeah. So yeah, that's the giveaway. I just want to somebody will get this. And all of you guys are eligible, if you're a registered member. Everything's chill. Oh, okay, thank you. Well, that's it for today. That's like the workshop. But yeah,